This is part 3 of my rebuild of an old M-Head Bridgeport milling machine. If you've missed part 1 or part 2, there are links below. There are chapter markers below if you want to skip ahead to any of these particular sections. And there are links in the information section below the video for access to these documents, which may prove helpful. I had hand scraped the table's dovetail ways in Massachusetts, but didn't install it on the saddle until months later in Arizona. Sure enough, it was binding a little bit on the ends. I rigged up a measuring device and attempted to take the warp out of the ways. After 4 or 5 more scraping passes, it moved smoothly all the way across the longitudinal axis. After mounting the table, I scraped the top, just to have it look nice. The knuckle, basically a swivel adapter, allows the head to be angled in both planes. This was just a simple refinishing operation. Next, I installed a digital readout, a DRO. I installed the Shooting Star DRO on my previous Clausing milling machine. It worked well for me, so I ordered a new one for the Bridgeport. Unfortunately, the owner of Shooting Star passed away a few years ago. I noticed that you could still order a Shooting Star DRO from smithy.com, but I don't know if it's actually the same brand and that works the same way. Nevertheless, Shooting Star DROs have been around for many years, and this is how I installed one on my milling machine. One advantage of the Shooting Star system is that you can cut each scale to the exact length required. By comparison, DROs using glass scales can be cut, but cutting the scale voids the warranty in most cases. For this machine, I bought a 3-axis DRO. Some people put the 3rd axis on the head. I chose to put it on the column. I plan to install a cheap digital indicator on the head later. The DRO installation was straightforward and much easier than the installation on my Clausing mill. On the back side of the table, there were 2 large coolant system drain holes. I plugged these before installing the X-axes. They were both 1/2 inch NPT, so I bought a couple of plugs at the local hardware store. They only went in a couple of turns, so I tapped the holes deeper. To avoid the cost of a tap, I turned a cheap plug into a tap by grinding a slot in it. I installed the plugs and sawed off the ends, then filed the stubs flush to the table. The X-axis power table feeds on milling machines are like DROs. To quote our name's founder, Ron Ginger, once you have one, you wonder how you ever got along without it before. One of the reasons I wanted my old round ram M-Head Bridgeport was because it was the smallest Bridgeport milling machine ever made. Another aspect that made it desirable to me was the fact that it had the short 32-inch table. Unfortunately, it also had the original Bridgeport longitudinal power feed assembly, which extended the length of the table another 4 inches from the stock 32-inch table. I figured the short Bridgeport with the small table would just fit in my basement where my old Clausing 8520 mill used to sit. The massive and heavy assembly also came with no motor. I didn't care because I never intended to keep it anyway. Fortunately for me, a friend at the NAMES group, the New England Model Engineering Society, wanted the parts inside the old power feed and was willing to trade me a much needed belt housing and put new bearings in it. My old belt housing was usable but had some cosmetic problems. I had a Harbor Freight power feed that I had installed on my Clausing for years, and I liked it a lot. It was difficult to install on the Clossing because the unit was designed to fit a Bridgeport. I knew I would have to work some magic because the power feed is designed to replace the manual crank, not the heavy Bridgeport longitudinal power feed assembly. I was able to succeed with the Clossing, so I figured I could succeed on the Bridgeport. I sold the Clossing mill with the drive installed and ordered a new one from Harbor Freight for $179. This was their lowest price unit with 135 foot-pounds of torque. The custom bushing, the left item in the picture above, was the only part I had to manufacture. The item on the right was the bearing race that came with the power drive. The bushing inside diameter is for a sliding fit over the longitudinal feed screw. The large outside diameter was some random scrap diameter. This is only needed to give a shoulder to the smaller end, which is a sliding fit with the supplied bearing race. The length of the bushing was such that the end result of the replacement of the new bearing race was in line with the end of the roller bearing of the power drive as shown in the next two photos. At this point in time, I had mounted the power drive but needed to add two keyways like the original shaft, except closer in. In the photo above, I mounted the brass bevel gear dial and dial lock nut so that I could make a mark on the shaft with the felt tip pen to determine where I would cut the first keyway. I cut the keyways with a cutting wheel on a Dremel tool. It was crude, but it worked. I would have liked to have cut it with my old mill, but I sold my Clossing and I had to get my Bridgeport running before I could do any milling. Next, I mounted the ball crank handle so that I could again mark the location with a felt tip pen and cut the next keyway. Next comes the moment of truth, where I cut off the end of the feed screw off with my hacksaw. There's no turning back now. If I had a lathe large enough to handle the long feed screw, I would have used it to cut the threads. I didn't, so instead I cut the threads the hard way. I filed the end of the longitudinal feed screw down by hand until the outside diameter was appropriate for cutting threads for the nut that holds the ball handle for the crank. I used a machinist clamp for a file guide. I would take 10 strokes with a file, then rotate the handle 40 thousandths on the left dial, and then take another 10 strokes, then rotate. All the while, I kept checking the diameter with a micrometer. As I approached the desired diameter, I took less strokes and rotated the handle 20 thousandths per filing cycle. To thread the end, I simply used a manual die, and I was very careful. Above is a picture of the completed installation. When you put the nut on the shaft, this is the first time you will actually compress the bevel gear against the gear in the power feed assembly. At this time, you will have to add the supplied washers and shims as appropriate to get a nice feeling moving mechanism. Not enough shims and the handle will take considerable force to turn and the gear will make bad sounds. Too many shims and the gear will feel really loose with too much backlash. This also adjusts the spacing that you see between the power feed casting and the indicator dial. Note the black spacer between the brass bevel gear and the handle is supplied with the power drive kit and is necessary for the handle to clear the power unit below it. The installation of the limit switches was simply one of bolting them in place. It was a lot harder on the Clossing. As always, thanks for watching, and I hope you enjoyed the video.